So, okay. All right. Did you get, you don't know the instructions? Let me tell you what's going on. Yeah, it's on Discord. Open this link, and you'll go through a whole thing where it says you'll have to add this one thing, okay? So you'll take that app, and then you'll add this thing called Google Colab. You'll get there by going to New, add more apps, and then it'll come up there. So first, just click the link, and then I'll help you through it. But does anyone else not have the copy of the notebook open? Okay, good. Second thing, Javier and Sohi, can you guys pull up your phones just to scan this?
No, that's.
You got it? Okay. Okay. Do I have like 5 more rejections on the video this week? I hate it. I hate it. I hate it. It's awful.
I didn't apply this season because last one was so. I applied to every one of the roles and got rejected.
I think I did that this time. Okay. Anyone not have it set up yet? Okay. Are we good to go? Everyone's checked in?
Do you need help?
No, it's just white.
So did you download it? Probably. That's okay. So first thing, go back to Red.
Like this, like.
No. Go back to your browser. Now, if you're go to like Google Drive. More. Next one. Go back to that tab for a second. Copy it to your drive. Okay. Anyone else not have it set up? Okay, we're good. Okay. So first thing, while everyone's here, can you guys run this first download script right here? This will just download some of the data sets that we're going to use later on. It's so very top title. Second thing will be run this to prepare your data. So if you just do that one click, it'll do the thing. You should notice on the side there's a check mark if it ever works. If it ever fails, you'll see a red X, and then when it's going, it'll just be in a little circle. That's the general rule of how Colab notebooks work. Good to go. The way I like to do this, if you guys have questions, please just raise your hand and tell me something's wrong or not working. We'll go through it back and forth, and then we'll get it working, okay? So let's get it rolling. So before you guys actually do any big thing with AI, you guys have to first understand what's your tools to first get in data, process data, and then push data. And so those are the kind of tools we'll cover today. The first one we'll cover is called NumPy. I think it's numerical Python is what it stands for. It's just any basic sort of, it's almost like linear algebra inside of a library. So we'll start just by importing the thing. It's NumPy as NP. That seems to be the universal way that people name it. And so once you run that in, we're going to start with the first data structure, which is an array. You've seen this before 1,000 times, whether it's a Java array, a Python list. If I run this code block, and if I get my A, I can come out and see what's in there. Okay. So the cool thing is that they call these ND arrays. It just stands for the dimension of your array. This is kind of the same thing that you'll do in actual machine learning. We just call it tensors because we want to feel special. The same thing is just the dimension is what matters here. Okay. So we did this. It's a one-dimensional array that's holding this float data, right? So let's go from one-dimensional to two-dimensional. The second thing we're going to do here is run the B array, and once we load it in, we can add in an extra print statement. I'll do that just to show you guys, save you guys the expense. Right there. There's B, and you'll notice that there's two arrays. So this is each a row of data. So there's two rows, each with 4 elements, and so it would be a 2x4 matrix, right, that we're doing here. So if anyone does not have any questions, let's roll into the first exercise. What I want you guys to do here is create a single NumPy array, the same way that we did before, and assign it basically your top 5 favorite cities' weather. So find it online, do whatever you want, make up data if you want it, but put that into an array of size 5. And the second thing I want you guys to do is just pick 5 numbers that you like, and then put that into a second array. And so the last thing that you'll do is that you'll add them together. So find the weather is the first thing, 5 cities. Yeah.
5 days, 1 city.
Sorry?
5 days, 1 city.
Oh, I apologize. Yeah, let's do that. Okay. So next 5 days. Okay, is everyone good? So let's do that. We'll come back in around 2 minutes. Just raise your hand if there's anything you can't figure out. I forgot.
Control and then plus to zoom if you.
Control plus plus, that's why plus plus?
Oh, just 1 plus is fine.
Okay. That's what our weather should look like, dude.
What is this in Celsius?
Oh, sorry. Let's see, can we convert it? No, because we're Fahrenheit build. Okay. Anybody not get it?
Bad website, weather.com, fuck you.
Okay. Good to go? All right, let's roll. Let me just get the weather for here. 15, amazing weather. Unfortunately, not gonna last. I think we get snow this weekend or right after. Anyway, 64, 48, 39, 48, 54. So what we'll do is that we'll initialize a weather NumPy array. By the way, if I'm going too fast, please raise your hand and just say slow down. That's cool. 64, I'll just make up numbers.
48, 39.
52, right? And then my favorite 5 numbers. 10, 6. Okay, those are my favorites, and then let's just add and subtract them and see what happens.
Actually, wait, can anyone tell me what happens if we hadn't subtracted before this is run? What behavior did you guys see when you tried adding those 2 arrays?
They align?
Yeah.
Yeah.
The first one goes together.
Right,
Okay.
exactly. It's an element-wise operation. It adds the first 2, second 2, and then third, and so on and so forth.
Yeah. And that's the core thing. As long as your dimensionalities match, it'll always work. If anyone tried doing one of them 6 vectors and one of them size 5, can you guys try that and see what happens? Yeah. And that makes sense, right? See what that comes out with. Well, yeah, that makes sense. And so let's say I added an extra dimension. I would obviously get an error because we can't actually cast these things to each other. If it's a 6 dimension and a 5 dimension, we're asking for trouble. So let's go back to what we had before, and we're good to go. Broadcasting is just a general term of like shrinking down a data structure into something you can work with on a singular level. That's something you'll deal with in general programming all over. Anyways, so now you guys have started with the basic data structure, which is the NumPy array. It's core of everything, whether it's 1,000 dimensions or just one. The next thing you guys should really know about is the actual go-to functions when we're using NumPy. There's a couple, like we're going to start with, which is shape. Like I mentioned before, the most important thing about this whole stuff is that each matrix has its own dimension, and we can kind of get those dimensional shapes just by using the shape function. So if you remember, the B array from earlier was just that 2-dimensional one. It was the 2 rows of 4 columns. If you tried it on the A dot shape, you would probably notice something it's a singular dimension. You can try that on your own if you like. But that is shape. You'll use that a lot whenever you're checking your data. Sometimes you'll set up the dimensions wrong and you're like, why doesn't my model propagate correctly? And it's because you just specified information wrong. So that is shape. The next thing will be linspace. Linspace is, as the name suggests, it's just a linearly divided space. So in our example, we're going to have a range from 0 to 100, and we're going to have 6 numbers that evenly divide them. So if I run it here, 0, 20, 40, 60, 80. Now before I run the next one, can you guys guess what A range would do when I do 0, 10, and 3? It would do decimals. What do you think the array would have inside of it? That's close. Any last guess? Okay, so the step quite literally just means how far we step on each increment. So it'll mean that we start at the very beginning of our iteration, which is 0. We'll make a step of 3. We'll take another step of 3, another step of 3. And what's special is that you don't make an exception if you step over the limit. So if I made this up to 13, I would step to 12, but I wouldn't step to 15 because 15 is over our bound. As a matter of fact, if I went to 12, I don't think it would work. So that's an important little syntax note to keep track of. Okay, and the cool thing, I probably could have saved you some time earlier. We can generate random data very easily in NumPy. We use a random.rand function. It creates an array that we specify the shape for, like you just saw, and it'll just fill it with completely random values. These like automatically go from 0 to 1, but I can show you in a second that you can put them to pretty much any range that you like. So let's start. If I want to get a 4-row, 5-column matrix of random values, I would do that. And there you see. Each row is a completely like randomly generated number from 0 to 1, and we do that basically 20 times. Yeah. Now, if you wanted to change the bound of what these numbers go to, you can see that in the next one, we'll be able to multiply by 100. Now, the one thing before I run it, I just want to ask, do you guys think that the new array will be bounded by ones, or do you think it'll have decimals in it? Decimal? Yeah. Good guess. And that's because we're not really casting anything about the NumPy array to change. It's pretty much only dealing with floats still. That randomly generated stuff from 0 to 1, we basically just multiply it by 100 and make no change. Okay. Oh, this is important. So when we generate arrays, it's also important that you know what kind of data type is inside of there. When you're dealing with actual machine learning models, what happens very often is that your data structure, the actual types that you can play around with and things you can change, depend from like data type to data type. So if I'm making a straight just like a tensor that I'm going to pass forward on, I can do that. But say I had a tensor of like strings or names, right? I obviously can't backpropagate on names. So just to show you, we're going to do the same step function that we did earlier, but this time we're going to see what kind of type it is. N64. And like we saw, these, what's special about them is that they are ints. They're not floats like here. And so they would be obviously going under the int64 data type. Cool. Okay. If anyone does not have any questions, let's go to the second exercise. I'll read it aloud just to get you guys started. So we want to use the shape method to find the dimension of an array containing the weather of your favorite city. We used that one just before, so if you know what to do, it's a pretty straight shot. Next, I want you to use the linspace to create an array of 5 evenly spaced integers between 15 and 45. And last thing, create a 3x6 array using random.rand. Bonus points if you use a range for this second one. Oops. Okay, I'll give that 5 minutes. Raise your hands if you have any questions, okay? Today is the IROS deadline, so my entire lab is completely full. Yeah, I was modeling for a nerve, so like they sat me on the table. They had me like going through my like documentation, and they just put like 4 drones to like capture the nerve.
Wow.
Yeah, so
They made you a model.
yeah. We'll see. We may. If I want to face some paper with no authors. Okay.
It would be so cool. I want to give a haircut and I could see if you were playing all kinds.
Yeah, no, it's bad. Even the professor is just there, just like working on like people's projects and shit.
It's high quality, but actually.
Okay. That's the most academic thing I've ever done. Okay. Anyone having trouble? Did anyone get it using A range instead of linspace? Did anyone try to use A range instead of linspace? Yeah. You guys work? It's okay. You okay?
No.
I can come and look, but I think you want to type it up then? We're pretty much ready to go.
Yep, of course.
Yeah. Okay. We get to go. Okay. Last thing will be operations. So as you guys have seen, you guys have been able to initialize the data structure, make some basic operations on it. Now we want to actually combine them together to make something pretty useful. So there's a lot of stuff that you get off the bat. Pretty much all of the arithmetic that you just saw is available and usable by NumPy. I can come and just run it just to show you. So we'll initialize a 3, 4, 5 array, 1, 2, 3 array, and then we'll add them together just to see. Okay, so as you guys can see here, The first ones that you noticed work pretty much the same as we saw in the very first exercise. We just added them together, so 4, 6, and 8 is pretty normal. Subtraction is also very normal. 3 minus 1, 4 minus 2, and then 5 minus 3. The thing that's a little bit more interesting is the multiplication and division. Those scale up based on which one you broadcast to. So the division goes from the element of x to the element of y is what's multiplied together, and then the element of x is divided by the element of y. The power pretty much works the exact same way. It would be pretty much equivalent to saying, I believe that's correct. Let's see if I'm wrong. Yeah, the exact same thing. So x to the power works the exact same way as if I could have just multiplied it together, and that's just the definition of exponents. Okay. In order to have like actually fast operations though, you want to keep things within NumPy. The cool thing about NumPy is that it pretty much all works at a lower level C, and that works way faster than having it cast up to Python. So basic things you could do are add, subtract, multiply, and divide, as we just saw. We're going to go back to that 3, 4, 5 array and do all these operations the exact same way. So when I add, I have 4, 5, 6, subtract, 1, 2, 3, multiply, and divide. Power works the exact same way as well, as if I would know how to raise to the power of 5. Anyways, this is the same. So now that we know how to do basic arithmetic using NumPy's functions, how do we actually get data out? It's pretty infeasible for me to look to a 1,000 by 1,000 array and figure out what's my data there. So what we're going to use is we're going to use these things called slices in normal Python programming. And so we'll start by just showing you what this looks like. I'm going to start with that A range of 12, and I'm going to multiply by 5. So each element, like we noticed before, is broadcasted upwards. 0, 1 times 5, 2 times 5, 3 times 5, and so on. But say I did this to be like 100. Well, first I will learn how to count. And second, I would go up to 100. Finding the 45th element is going to be really painful, right? So what we could do instead is pretty much just ask NumPy to give us the element itself. And it'll do that without a problem, just like normal Python lists. Just know that NumPy arrays are always 0 index. Those are different than things like MATLAB, which does, I think, 1 index based arrays. If I access this, this is giving me the 3rd through 6th element of the array. Now, let's try to put them together. Instead of adding them or trying to turn them into strings or something, NumPy has a built-in way to basically slap 2 arrays next to each other. So as you saw before, that S array, that big size 12 array, is now concatenated with our A array from the very start. And now we have 2 rows, we have 1 row of continuous data that's concatenated. Now, say we want to actually separate data, right? Now we can put data together. Let's start with a Z array, and let's split it up into, basically evenly split it in 3 ways. So if we do that, what do you think the output array will look like? Any suggestion?
There's going to be like 3 arrays.
Yeah. So what do you think the final dimension will be?
3 by 3.
3 by 3? Yeah, perfect. And so each one gets its own array call. And so if I did, let's say, t-type, I think that should work. Oh, you're right. And so that rule still applies on the rows that you deal with. Okay. Now, what are we doing? Like we just said, the split array shape is a 3 by 3. 3 rows, each element has 3 columns or 3 pieces of data.
But the split array function by default converts it into a list, not into a new array. There'll be 3 arrays or 3 array elements with those 3 3 elements each, right?
Yeah.
But it's not a new NumPy array yet. If you want to convert that to a NumPy array, basically stack all of them together, you would wanna encapsulate the list with the np.array function, and that converts it into the full 3 by 3 array. Then when we run shape, we get 3 comma 3.
Yeah, there's also a reshape function. We could actually do that right now just to show. So this is what you saw where you had an array like this. Let's just add one extra code block. So let's do np.reshape z, and I think it's 3, -1. I think so. We'll see if it works. Yeah. So this would how you'd want to do it if you want to make an actual lower level 2D matrix. What we're doing right here is that we're saying that I want NumPy to split this up such that I have in my first dimension 3 rows, and basically figure out how the rest of it's going to work is how -1 works. If I replace that to just say 3, it would pretty much work the exact same way. Say I did 9 instead, and I would calculate how long it is or whatever. It would flip it that way, right? So you can reshape things pretty much how you want to your will. And that's the power of the reshape. It's just kind of messy if you want to keep track of dimensions, but just keep that in mind, okay? Okay, so good. Now you guys have data structures, methods, operations, and also splitting up data. So let's do a final operation. So using a working text file, you'll get an array of 5 numbers with increments of, I think it's increments of 5. I did something wrong.
Increments of 10, call it Oreo. They just 2 list items in the middle.
Ah, okay. I apologize. Okay, so name that Oreo, retrieve the 3rd number, so use that 0 index that we talked about earlier, and then create a separate array of 5 numbers with increments of 15. Call that milk, and then the last thing is that make sure that you can retrieve the first number, and then do the last thing where make sure you can calculate how many Oreos you can drink with that much milk. Okay, so we'll give that 2 minutes, give it a try, and then we'll come back around, okay?
Sweet. Yes, of course. Using the arrange method, create an okay. Create an array of 5 numbers.
0, 5, and multiply by 10.
Okay. I'm pressing the wrong shortcut.
Okay. Just get the second element. Alright, sorry. Tim.
Fuck, maybe yes. Create another array of 5 numbers. Increments of 15. Use any method. Yep. Actually, introduce the first number. Can you eat those many Oreos and drink that many cups of milk? You decide.
Okay, well, obviously. What's your life doesn't Okay. Congrats. We completed the first module. I will give you guys like an extra minute or two just to eat, look over stuff, and then we'll get going with
Pandas.
which is a lot cuter. Also, Pandas documentation is pretty good. I'm not gonna lie.
Oh,
They all
yeah.
have great documentation.
Although I have really good documentation. Documentation is amazing.
Yeah.
It's like seriously.
Everyone sees it. That was so cool though. The fact that you can have a VM just spin it up as like
It's not even a VM because it's using the same kernel. So it's just user space, which is genius.
Yeah. I think it was so smart. The funny part is that on Windows, they just like spin up a Linux kernel. Though.
Yes.
So that's the only place where it's VM.
Exactly.
See, people are like systems research doesn't matter at all, and that's like a direct counter to that. It's like you know systems well, then you can do something cool like that.
Yep. All research is awesome. I don't think I've seen any research that isn't.
People dedicate their lives to this. It has to be cool. People dedicate their lives to it. Can you imagine this? I can't.
It's one thing to dedicate your life to, man.
Okay, academic. Okay. You want to try this?
Okay. All right. Awesome. Everyone, we're good. Let's start talking about pandas, right? So NumPy is a fantastic library. It is very low level to a certain extent because a lot of larger libraries like pandas use NumPy under the hood because of how efficient NumPy is, right? So we are going to go to a little higher level because there are a lot of functions that we want to implement with NumPy, and pandas kind of simplifies that for us. So pandas is a data processing library, so, not completely dissimilar to NumPy, but it has a lot of high-level functionality that is very relevant to us, right? So when you get your data originally, it's going to be an absolute mess. It is very hard for computers to understand data in the same contextual sense that we do. And pandas basically is what allows us to make sure that the computer sees the same data that we do in a much more sensible context. So let's see what's on the notebook. It does not zoom in like this.
It does.
There you go. Okay.
Sorry,
so-
was that a problem earlier, the Zoom? Was it hard to read?
No? Okay. All right. Awesome. So pandas is an open source Python package, numerous tools for data analysis, yada. Okay, let's talk about series. Series is fun, right? So series is a data structure that is very similar to the one-dimensional array that NumPy has. It can store, as you would guess, a series of data, right? You give it a sequence of numbers, it has to have just one dimension, and pandas will convert it into its own data structure, and you can do a lot of fun things with it. So to import pandas, all we need to do is import it, and PD is the abbreviation that is very commonly used. On your local computers, you would probably have to install pandas as well as NumPy, and you can just do that using pip and NumPy and pandas. But Colab is awesome, it provides it for us, so we don't need to worry about it. Anyways, we can create a variable. So in this case, we're going to name it decades, and we just encapsulate this NumPy array, and we do that and we print it out, and we get the printed version of this same array information. This can also be just a list. You don't need to convert it into an array before you convert it into a series. but the effective behavior is really one and the same thing. If you okay, that's if you want to extract the array directly from it, I'm pretty sure you can run the array
I
function.
think it's 2 numpy.
Oh yeah, it's 2 1. My bad. There. Yeah. The 2 numpy function, and that will give you your original array back. So, anyways, we will keep this to the series, and a very straightforward exercise that we can work on now is just creating a series for the lowest GDPs in the world, and you're given a list of these 4. So all you need to do is create a series with these 4 elements.
Okay. And as a tip, just notice when you started before with decades that there was an index here as well, right? When you want the data to be outputted, you don't want to say 0, 1, 2, 3, 4, and then say, oh, look at the side. This is the 0th country is Uruguay. The 2nd country is Portugal. So make sure that when you guys do this, you guys also change what the index is. We left a link inside to the Pandas series documentation. Make sure you take a click there and just look how you actually change what the index is, because that'll be useful and make your data a lot cleaner. Is that what you use instead of Anaconda?
What?
Like having an ML bin, like basically having an ML virtual environment instead of bin. I started using poetry again. They'll do the same thing.
Yeah, sure. That's true. All right. Updates. Did everyone get it? If you did not, could you raise your hand for me, please?
Would you guys like another minute? Yeah? Okay, we'll give it like 2-3 more minutes, okay?
Awesome.
Has anyone studied outside today? Just because? No? Yeah, one of my classes, we basically convinced the professor to lecture us outside. We got nothing done though, so it was like a double win. Nothing, I was just worried that we were showing it.
Well, they have access to the.
No. I thought that was the solution because I saw data for like 2
Oh.
weeks. Anyways, don't worry. Okay, everyone's good? Okay, let's go with the solution.
Sweet.
Use a,
Why do you have the cover on your thing?
The cover, you can take it off. Okay. Give it a run. Print outside. Did anyone not get these? Okay, we're good to go.
Sweet. Okay. So this was an example of your one-dimensional array, right? That NumPy basically encapsulates. So the general idea behind pandas is to basically host your entire data set, especially if it's text-based information, right? We can use pandas to import a CSV directly into an object, and this direct object that we imported into is the pandas data frame. It is one of the most versatile bits of classes that are out there, and it's basically used everywhere, right? So we don't have a CSV for today, but if we did want to import it, we could just directly pull it. It is there? What?
We also use it a lot later on. There should be one CSV we read in for.
Okay. All right. My bad. Anyways, for now we have this dictionary over here, right? It has a list of animals. It has a list of ages, weights, as well as length. So we're basically indexing a bunch of animals, and this dictionary is basically your standard Python dictionary, right? There is nothing intrinsically exciting about it, but we can convert this into a data frame, and if we run it, it's gonna basically print it in a much more fancy way, right? This also, similar to NumPy, uses a lot of low-level libraries in all of the operations that we will be going through, and that's basically the entire relevance behind it, because it performs all of the operations much faster than Python can. So,
Sorry.
right, one interesting thing as well is that this data frame has a list of headers, right? So we had the keys from the dictionary over here. They automatically were converted into the headers as opposed to being part of the information. When you import from a CSV, the first line by default is considered the header line and will constitute, and those values basically come in over here. If you don't have it, you would have to basically specify that there is no header, and they would ignore that, and you would just have numeric values for your header. But that's basically your data frame. So let's talk about the various methods that we can use within pandas in order to basically run operations on it, right? So first we have the unique function. It returns all of the unique values that are present within a given series. Oh, also one more interesting thing is that all of these, this is a multi-dimensional array, right? It's encapsulating a multi-dimensional array. So we can also look at this data frame as a collection of series. So we have one series called the animal series, another age, another weight, another length. So we have basically 4 series that are packed together to give us our data frame. So we can run series operations on those individual columns. So right, first there is our unique function. We can run the unique function on the animal series, and it will give us all of the unique elements that are present. So it will basically give just one instance of each of the values. We can also self-reference this unique function. So instead of calling pandas.unique and then specifying the object, we could just do animal and then give us, so animal data frame, and then specify the series, and then just call, what's up?
No, go ahead.
Unique on it, and then it will basically give us the exact same thing. So here it's basically just a self-reference. You will see both of these different use cases, or both of these different syntaxes when you run your actual code, but it's one and the same thing. So, alright, the next method that we have is the describe method. It returns summary statistics of the numerical columns. So if you ran this on animal, it would probably give you an error. So let us try this and look at the output. So we have a couple of different values. We have the count, so how many different unique or how many values are present. We have 14 for each of them. The mean of them, the standard deviation, the minimum, 25th, 50, 75th quantile, as well as the max. So yeah, that is just a set of summary statistics. np.number returns the numerical columns and excludes the other data types. So over here we use this include argument and specified np.number, so it just gave us the numeric columns and ignored animal. To filter in pandas, we can also use brackets. So let's run this and then see if we can deconstruct this and sort of build up to it, right? So we run within this animal data frame, we perform a filter operation, and we want to pull out all of the animals whose weight is greater than 10, right? And the way that pandas actually does this is if we would run, say, animal and then just pull the weight, right? We get this individual series, right? Can anyone tell me what happens when I will run greater than 10, right? So this before, if we had to add 10, for example, it would basically perform an element-wise operation and add 10 for every single one of them, right? So this is for numerical. We have done that for power, for addition, multiplication, everything, right? What about Boolean operations? Does anyone have a guess for what might show up?
It will only print the ones that are greater than 10.
Close. Other guesses?
Zeros and ones. Zeros for
Yeah, actually, yeah. It's 99% of the way there. I would give you that. So what it does is it just performs Boolean operations, right? Everything, when in as a general rule of thumb, you can look at it this way, right? Whenever there is a single operation, that single operation is performed element-wise on the entire series. So that's exactly what happened, wherein it presents a false if it's less than 10 and true if it is greater than 10. If you convert that to integers, it would be zeros and ones, exactly like you said. So awesome. Now, if we want to get the actual values rather than just true or false, all we do is specify encapsulate this with the animal data frame itself. This gives us the original statement that we had, wherein it takes the false, and if it's false, it will not get it. If it is true, it will get it, and that gives us the final output, right? So yeah, that is filtering. Python is wonderful, it's intuitive. We pointed to animal and then to the weight. We filtered for numbers greater than 10. So yeah, what if you want to find rows between a certain subset? We can simply use the AND operation. This tiny subset basically does this subset does the exact same thing, where it gives us true and false values for those particular for the element-wise operation that it performs on every single element, right? And if it's true and true, it will reduce to a single true value. If it's true and false, or false and false, it's going to give us false, and then it will not filter, or it will not have that present in the final output. So if we run this also just filters it out based on the two criterion that we have provided. These two criterion can be completely different, so we can filter by length as well as weight as well as age. That's all perfect. Everything works.
Question: why do we not get to use the and? Meaning, why is the ampersand used?
Oh, sweet. Okay, so
I don't think it matters actually. Try it.
Well, ampersand is for bitwise, right?
Yeah.
So if I do true and true, okay, wait.
No,
Yeah,
use
it isn't.
double ampersand.
Right, exactly. So this will work. So because it's because it's bitwise. Oh, you meant and like this.
I think it's.
Oh, that works. Yeah. Should this work? Ooh, the value for series is ambiguous. A empty.
Yeah. So
Okay.
that's just a small tip. So because we're working with Boolean operators and we want to actually do something, if you're doing 3 or 4 or 5 things, you can't really use the Python AND operators. I believe all you have to do is use that ampersand or use the brackets instead. can you try that? Use the showing the OR as well.
Oh, yep. This should give the same error, and if you just use the
I think it's pipe.
yep.
Try it. Yeah.
So this is basically a bitwise OR. So for Boolean operations, basically. So I'm gonna try a quick experiment. Let me see if we. Okay. Yep. Okay. This is the same error that we got, right? And if you do this, yeah, okay, awesome. So what's happening over here, right, when we have this AND statement, it is comparing those two different arrays, and it is basically saying that we cannot determine a single value from this because you are asking us to compare two arrays, right? If there was a single value, it would be able to, Python is clever enough to type convert by itself and give us something that is relevant, which is why if we run just true and false, it will not give us an error. But if we do that encapsulated with an array, then it is a problem because it becomes ambiguous, right? NumPy doesn't know how to deal with it. Python doesn't know how to deal with it. They throw an error back to the developer. The way we get around it is by using the bitwise operation, which will basically just do everything the same operation element wise. So true, and then false, and that will give us true and false. Because true and true, obviously true, and false, obviously false. But yes. So yeah, that is interesting. TIL. So right. That is data frames. We have one last function that we'll cover before we get into the exercise. That is the GroupMy method. It involves grouping data around a particular category. So if we have a lot of common elements, for instance, under animal, right, you can see there are a lot of elements with hamster. What if we want to perform comparisons for just hamsters or for just cats or, all right, I think, yeah, or snakes? There's 2 snakes and 2 alligators too. So if we want to perform comparisons based on the elements, right, we can do that using the GroupBy function. It will give us a list of data frames, and each data frame will contain the particular type of animal, right? Because we are grouping by animal. So this gives us the weight, the mean weight for each of the different types of animals. So it's a very, very easy way to access the animal groups, right? Or perform inferences based on the animal groups. So if we were to look at the type of the of whatever is returned over here, you would see that there is a list similar to how array split gave us a list. Oh, no.
Print
Wow.
it out, just show.
For print would probably give us something weird. Yeah.
Okay, that actually makes sense. But yeah, just as a fun fact, if you guys ever written SQL before, this pretty much works the exact same way internally. We're just pretty much treating the data just as like whatever type it is, and we'll group it how it works together. It's just cool because whenever you guys get to web development or whenever you guys try to explore that, the skills will transfer over pretty smoothly.
Right. Awesome. Okay. So for the exercise, right, there is the UN dataset. Create a frame using North Africa, Sub-Saharan Africa, Eastern Asia, and Western Europe. For these areas, create columns based on these 3 categories. For the year 2005, sort those countries out that have infant mortality between 30 and 50, and find the highest infant mortality for those 4 areas. So we give it a moment and go through the solutions.
Yeah, no, that was good. Wonderful.
What are you thinking?
The name of the song is Wonderful, but
Oh, I know.
I think it was a Badshah remix of it.
I wonder where the mic is.
Might be up higher.
Oh yeah, it's close to here. See, watch.
Oh, that's right there.
Yeah, got it. One data set is a PDF.
That's fine.
That's me.
Oh. Well, I hope they're not. Please don't load a CSV for this problem. Just try to pick out the data from the PDF.
It was compiled using Microsoft Word.
How do you know? Oh.
We'll have to actually
Yeah. That's crazy.
should probably use the Access TV or something like that.
Is this French? Is this by your choice that you chose the French word?
No. This is the one. This French and
Oh, I did not see that. Just did we get these columns? No, we did not. Yeah, I thought we'd use countries as columns. Or like index. Guess not. Oh, yeah.
this looks like right. Why we typing out the entire CSV? We shouldn't call like CSV.
Yeah, we shouldn't. But it's okay. It's just to get the feel of it.
Yep. What does this button do? Oh my god, that's ugly. Like what you see for
Oh, it's interactive? Oh, that makes sense, dude.
oh, there's a person for you. That's
It's not bad at all. Okay.
You know there's SQLite in the browser now? Did you ever read the article I sent? There's a SQLite for the browser.
When did you send it?
I don't know, maybe a week or two ago. I saw it on Hacker News. I thought it was cool.
Oh, that is cool. Okay, how do we go back?
Hold on. Start up. Or we just run it again.
Probably. Yeah. It's cool, but they need to update the UI. This UI looks very cool with the what is it called?
No, the alternating colors is very useful.
Yes.
Prevents the eye strain. Okay. Would you guys like another minute? Okay. Again, raise your hands if you have problems. We are here to help. Oh. That's natural. That's how these go. I don't know. Like I was talking to Jacob, like, how do you increase recruitment? How do you keep consistent recruitment over weeks? You can't, because it's sequential knowledge.
It's possible.
You know what I'm saying? How do you say like, oh, I want to come to this one instead of all the before? Yeah. We have a different market. Yeah. That makes sense. Okay. Like staff out of letter is too long. Are you taking this?
Which class?
Staff out of letter.
I don't know.
So it sounds like a pretty necessary data science class.
Oh, I think I did 355, which is.
Oh, we're already covered. Yeah, what are you taking this semester? I'm doing one thing that's like with the professor.
Yes.
Is that like independent study on this? Is that like independent study?
Yeah. I don't think it's set as an independent study class. Anyways, it's I'm taking 490 over. That is an actual independent study class. It's 690 with Ramiro, Deep Learning. There was
I did like 3 days this class last semester. Or barely like 3 days last semester.
no. 10.
10?
Yeah.
Oh, I have like 100 or something.
Yeah.
It's not too bad. Good.
Easy 3D minus, standing 3D minus.
Oh, okay. 3 including like Saturday.
I think so.
That is right.
So it was awful. What else? What else was I taking? What else? Oh yeah, 351 and stat 416 and
section in this fucking football club. He's wearing a Manchester United shirt. It's like fucking good. Never in my life.
Okay. From the looks of it, you guys are all good? Okay. Let's kind of go through what has to go on. If you want to, then you can take over, but I can probably do it. Let's just start by initializing the array. I apologize for making it super long, but we're going to start with just a dictionary just to make it easier to format. First label was countries, like we said before, or really like geographic areas. Sub-Saharan Africa. God damn. And then Eastern Asia and Western Europe. Okay. Second thing, like we said before, as well as the population rate of increase. I don't have these numbers memorized. We wrote it down earlier to save us some time for now. Did I manipulate on? Nope. Okay. And then it's 1.7, 2.7. Nah. I should keep consistency. I should have just done single quotes for consistency, but it doesn't matter at all. Yeah, I think in Python they're treated the exact same way actually. The reason why is because, like, say, to give you an example, like, right, then it would print out the with the quotation mark there. But there's no use for this point. Just pray that compiles. I do not want to debug this. Do the numbers look right? This is what we got from before. I don't know if we got the wrong thing though. Okay, well, let me. Okay. Did I do something wrong? Oh, yep, sorry. Cool. DF is just shorthand for data frame. I think that's pretty commonly used. And then the last thing was the filtering. Does this look right to everyone? These numbers? Okay. Then, like we just covered before in that big thing, in the data frame, all we're going to do is we're going to filter based off of what Boolean features we find to be true. And less than 50. Okay. Cool. Is that correct? That's the only one that's in between. That looks right. Okay. Last thing, let's just get the max. And that looks pretty correct. All right, awesome. So that wraps up Pandas, a very small but powerful tool that you'll pretty much use everywhere in your data processing life. The next thing we want to go over is visualizing this data. We'll cover two very popular libraries. The first one will be Matplotlib. Like it says here, it's a 2D plotting library which uses all sorts of graphs like plots, histograms, spectra, bar charts, whatever, right? And it's really easy to get set up with. We'll only do the basics just to show, but we'll start off with just the important. Just like the other ones, there's a pretty much unanimous way people import Matplotlib, which is with a PLT. make sure you include pyplot because that's the actual graphing utility. So let's do that. And then let's start over with what the pyplot is. Pyplot is the actual part of Matplotlib that gives you the functions that will let you graph images like lines, text, etc., right? And it'll let you figure out your axes and draw your visuals as you want. Let's start with a very basic example, which is with a x and y coordinates as you see here. I will do plt.plot and then plt.show. This loads it into a graph itself, and then this will actually visualize the graph for us. And there we go. As you notice, these are just the squares of what we had before. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Okay, awesome. You could use NumPy arrays here instead. It would pretty much work the exact same way. The whole thing is just, it's something sequential that we can work with. I think I'm good. Exact same deal. Awesome. Now, if you want actual pretty graphs, you want to actually label stuff on it. It's a very easy way to do that inside Matplotlib. All we'd have to do is use the title function, a x label for our x coordinates, as well as a y label for our y coordinates. Now, if we go ahead and run that, we will notice that, as we promised, the first plot is right there. The x label is there, as well as the y label. Awesome. So, if you're not just dealing with linear data, one thing that you would want to do is kind of get the graph of your spread of data. That's commonly done with a scatter plot. Let's start with a very basic scatter plot, as you will see here. Height and weight, we put a limit as to how far it'll plot out. And what you'll see here is when we do the scatter plot, these things are pretty much the exact same as before, but what you'll notice is a very different visual, right? Instead of reaching out super far, it'll look a lot more compact, right? It's a little bit hard to see and things are a little spread out. This helps us get a better idea of what the visual will look like and what a normal spread looks like. Okay? So there we go with scatter plots. And let's start with an exercise. So with the weights and the heights that we got before, can we do a general scatter plot of all this information? Also try to title it if you can. Which one needs the CSV?
C1.
Okay. C1 looks prettier in my opinion. I think C1 is prettier. Basic graphs.
I don't like graphing either way, honestly.
Yeah.
I use dataprep that just creates an HTML file for me that just does all the basic things AutoML effectively.
Yeah.
And then after that I take a look and that's my pre-processing, your EDA at least done.
Okay.
I don't, yeah. Graphs are boring.
But it's pretty. It's so pretty just to memorize like 20 lines of syntax. Just to. Don't you feel like that's so useful?
For the graphs that I do need to build, it's more like custom graphs that just is an assimilation of sample data. And for that, Matplotlib is better because they're structured it very nicely.
Yeah.
I don't know about Seaborn. Actually, I've never tried it, but over Plotly at least, this is Matplotlib was significant improvement.
Okay. Yeah. C1 just looks prettier in my opinion. Okay. Cool. Would you guys like another minute or two? Okay. Am I good to go? Cool. The code for this shouldn't be too hard. Let's just start with the actual scatter plot. Like we said, we already have the animal stuff from our data frame before. Let me just go up and check. Length and weight. So those are the two labels. Let's just go with that. Hi. And the X label, like we said before, is going to be. Oh, I think that's reversed. But anyways, let me see if I'm wrong. Let's show this data. Yeah. Is that correct? Let's see. Weight versus length. Yeah.
Weight should be at the bottom. No, this is yeah, correct. You're right.
Okay. Cool. Does everyone's graph look like this? Did I get something wrong? Okay. Are we good to go? Then let me hand it over to Janen. We'll go over Seaborn, and then we'll go on to the last cool part, which is linear regression.
Awesome. So Seaborn is a library that is much similar to Matplotlib, right? It's just another graphing library, but as Arfud put it, it makes the graph look a lot prettier. So that's basically.
I have evidence for this. I'll show you at the end.
Right. So to import it, it's as straightforward as that. And the syntax for creating the scatter plot, right? Instead of first defining the scatter plot and then having the X label, Y label title set after that, Seaborn basically does all of that within the function definition. So first over here we load this tips data set using pandas, and we have this scatter plot that we set, and that's basically all there is to it. We set our X label as total bill and the Y label as the tip. We set the data as the CSV itself, and it will give us a plot. This plot, I would argue, is quite similar to Matplotlib.
No. Once you put in the colors, okay, there's colors. No matter.
Okay, so this gives us a scatter plot of our data set. Let's actually kind of let's print the summary of the CSV actually. Okay, I will figure out the MacBook one day. Anyways, this is our original data, right? And we have the total bill data, which is a bunch of numbers, and the tip data are additional bunch of numbers, right? We use the scatter plot function, and we get a very, very pretty plot of the bill against the tip. So when the bill is the highest, they tend to pay higher as well. That is the general trend that we are observing, right? This is something that we can visually see. Because it's a lot easier for us to visualize this than if we just had access to all of the numbers. So this scatter plot, it doesn't discriminate between the days of the week. It is not a group scatter plot. It is just your normal scatter plot, right? If we were to set that categorical discrimination, we can do that using the cat plot function, wherein we basically give it the X value and the X value as our day and the Y value as the total bill. So we do that, and it will basically filter it out by day. So we have the day column over here, so Sunday, Saturday, Monday, whatever, which is why we are able to directly do that. If we had dates, we would want to use pandas to do a little bit of magic with their datetime data type, and then from there we would probably be able to get it into this format. So this format gives us the ranges of the bills split by day and just some general additional context to visualize. And as Arif said, there are colors, so it looks prettier.
Yeah.
So sweet, that's great. but we can go even further with this, right? We can sort this graph out by the time of day as well. So we can see how the tips differ or the bills differ by the time of day. So during the evening, you would expect it to go a bit higher because more people eat together, because they have friends and stuff and they do things after work. But anyways, so here is that differentiation as well. So this is split by dinner and lunch. So the lunch is the orange dots and the dinner is the blue dots. And you can see how that differs. So this restaurant gets a lot more business on Thursday for lunch than it does for dinner. So using categorical plotting, we can find a lot of additional features regarding the data and patterns using the various arguments. So in this case, we set the kind as swarm in order to prevent the overlap and basically give us the format or the data in this kind of format. So it gives us that additional label and that highlighting. So awesome. That is Seaborn. The hue parameter allows us to add another another dimension to group data by color. Swarm helps us visualize data more clearly by preventing overlapping points. And in catplot, the plots with the same data values will overlap on top of each other. So we can see there are a lot of data points around this region. So that's why the swarm allows it to basically show us that the quantity is higher. So, exercise. Time for one of the last exercises for today. Create a simple scatter plot comparing the size of the tip versus the size of the table using Seaborn. So, we'll give you guys a couple of minutes to get on that and we'll go through the solution.
Just a question. Like,
Yeah. Do we have an exercise for linear? No.
no, it's showing a symbol.
Gotcha. Okay, so we have time. I was worried because we were done like by 6:15. We were only done with 2, so it would take a while.
Should be on the line, right?
Yeah. Press the AF. Oh, it does it for you. Oh, let me just get my pen drive out real quick. Show your calluses. I want to see the difference between the calluses and the normal skin. I mean, I have one.
Do you want my calluses?
I want your fingerprints.
Okay. Any questions? It should be a one-liner.
Okay, do we have thumbs ups? Yes?
Yeah? Okay. We can just go ahead with it.
Awesome. If anyone has anything, please get them.
Yeah. Would you guys like another minute? Please object. You guys would? Okay. Let's just go ahead with it. Oh, what did I do wrong?
Type C. What is your computer lightning?
What? Oh, that's the wrong one. Okay. Are you right? Oh, you are right. Dude, I'm striking out. Yeah, perfect. This is the same, right?
Yeah.
Okay, cool. That wraps up Seaborn. So just to give you a taste of what an actual ML library would look like, we're going to start with scikit-learn, which pretty much has pre-built algorithms for all the most popular machine learning algorithms. Like we say here, things like classification, whether it's a cat or a dog, regression, what's like the mean of this like data, and how does our data fit along that line, and even like how do we cluster groups of people together? Can we classify them in groups? These are all sorts of things that scikit learns. It was probably one of the coolest things that I saw coming around freshman year. So very excited to show it to you guys. Let's kind of start with a very basic example. There's a linear regression of this big data housing set called the Boston data set. You'll see when we run it that apparently it has big ethical issues now, so don't use it for actual research. But just to give you the idea, train test split is just how we split our data. The train is what we'll use to actually train our model. Test is what we'll use to actually evaluate its performance. And the linear regression is the algorithm that we're using today. We're just going to fit into how well a line can go across our data. And the load Boston set is pretty self-explanatory. It's loading an ethically problematic set. So anyways, yeah, that's the data we'll be playing around with today, okay? So we'll run that, and then we'll head over to just show you what the data looks like. Well, sure. House prices, there's a couple of things. Median value, lower status, whether it's like an industrial side of town, and basically a bunch of stuff that you would want to know, almost in like your Zillow type thing, right? Just general things you'd like to know when you're buying houses in a certain area. Okay, so let's look at what a certain houses would be like. If we started with the first element in our house, right? We'd notice that there are a bunch of numbers and there's things like this, right? But there's no real label for it, so we can actually figure out what's going on. If we started with the actual labels and we associated and we knew what was going on, it would tell you the actual price and things like that, and that's what we notice when we actually run and get the price. Data is just giving you the actual scalar values, as you'll notice here. The labels are stored inside Target, I believe. Correct me if I'm wrong, but that's generally how it works. Okay, so now that we know how to access features and now we know how to access straight data, let's actually train a model, a linear regressive model, and just see how it fits to our data. So here we're going to do the train test split as I promised. Here we're getting the actual numerical values, and here's the labels for our values. This will stay the same over all supervised learning.
Maybe you want to explain train test split real quick.
Yeah. Train test split is just to show that when we train our data, we want to actually know that this is doing a good job and just not memorizing the data that we give it. So let's say that I want to give you maybe 70% of the data I have just to say, okay, here's what you get to play around with, figure out an actual pattern, right? And the only way I can evaluate that you've actually followed or found a pattern from my distribution is to pick out the other 30%, right? So if I randomly sample out of 100 people 70%, and I'd say like find the average height of these people, right? You find the average, and assuming that it's a normal distribution, the other 30 that I picked out would follow the same trend. And that's all we're really doing here. We're picking out a set of data, our X labels, which was our numerical values here. That's our train set, as well as the attributes for each of those training sets, and that's the Y train. Now, after we run it and we get our actual evaluations, we want to compare it against the actual data and the labels that we got associated. And so that will be where the X test and Y test is. When we feed in our model, we're going to feed in the X test because those are all the actual scalar values, and we're going to compare what it predicts to actuality. Okay, CLF will be the initialized linear regressive model. We're going to fit this model on our data. As I promised before, it'll be over the actual numerical values as well as the labels associated with it. Now, when we do our actual prediction, we're going to predict on our training set after we fit, and then we'll compare with the actual expected values. So here I won't tell you too much if I just showed you predicted and expected, but if I show you real versus fake, then you can see where we're going, right? This is the line where we're actually getting something correct. We're going along the actual value, and what we're figuring out is how far are we off from reality. So if I predicted that something would cost around $10,000, but in reality it was a little bit lower, then we would obviously see that we're leaning towards cheaper prices here. As we see though, because the data is well distributed, we pretty much trail along the average here, right? There's a stream of data that we're a little bit off with, but in general, our model fits pretty well. And we could really tell this by actually comparing it with the expected values. as you saw before, right? Now that we have a testing set to base it off of, we'll figure things out. This idea of testing and training set applies to pretty much all machine learning. Anything that has data, labeled data, is what we would have the split going with. We would also have an evaluation set, so it'd be train, test, val. Whatever your split is, maybe it'd be 70, 15, 15. And so while you're training, you could evaluate how your model's learning. After I've trained it maybe 10 or 15 times, I would want to compare it on my evaluation set. I would see that, okay, after doing this many training, it scored like 70% on a training set. Maybe it predicted with like 70% accuracy. However, after I trained it for 30 times, it scored like 80%. So there's something I'm learning, right? But yeah, this is just the first taste of what a machine learning model can give you. We're definitely going to go into more in the future. If there's any questions, please raise your hand, because that's what we're here for. I just threw a lot of words at you.
And for fun, I'm pretty sure you can use this same sort of bit of code with a little bit of modification for what your X data and Y data would be to train something for the scatter plot that we saw above over here. So you could try training it on this scatter plot as well, where you want to try and fit a line to this scatter plot, and if or with the information of the best fitting line, you would basically be able to evaluate what, or not evaluate, but predict what someone would tip based on the information that you have, which is the total bill. So that's the basic idea, right? We have a set of information and we want to predict things from there. We want to gather inferences from that data, and the correlation may not be direct. Machine learning basically allows us to find that correlation a lot easier. So that's where the fun is all about, and we'll probably be getting a lot more into that kind of stuff in the next couple of sessions. It's probably going to be Ritvik who will talk about it, but yeah. So thank you all for coming, and have a great rest of the day.
Cool.
Thank you. Alright, so what's your plan for the rest of the day?
I should probably figure out the Hugging Face thing.
Chill, I think.
Stop.